In this lesson, we're going to talk about patterns of the periodic table. Well, when we're looking at the periodic table, you can see two things in particular. One, you have columns, and two, you have rows. If you look here on the side, you'll notice that you have 7 rows. These are called periods. Now, periods tell us something very special about all of the elements that are on the same period, on the same row. And what is that? Well, they're all going to have the same amount of energy levels. So, for example, sorry, it's kind of hard to write with my mouse, but I think you'll get the idea. So, for example, if you look at all of the elements that are on period 4, all of these elements have 4 energy levels. They have electrons that are on the 4th energy level. Okay, so now let's take a look at the columns. The columns are very special because the columns tell us how many valence electrons each element in that column will have. So, for example, in column 1, you'll notice that each element has 1 valence electron. In column 2, each element that's in column 2 will have 2 valence electrons. Now, we call these columns something special. We call them groups, and sometimes we call them families. And the reason for that is because they will have the same, all the atoms, the elements that are in that same column or in the same group will have the same number of valence electrons. And if we remember, valence electrons tell us how an atom is going to react when it meets another atom. So all of these elements that are, let's look at group 1, they have 1 valence electron. So all of these atoms are going to want to give away their 1 valence electron. All of the atoms in group 2 are going to want to give away their 2 valence electrons. Okay, well, let's hop over to this side. If we're looking at this side of the periodic table, we see group 13 through group 18. Well, group 13 has 3 valence electrons. Group 14 has 4. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. And over here we have a very special group. They have 8 valence electrons. And what do we know about 8 valence electrons? They have full energy levels. They're full. We call these right here, this particular group, the noble gases. And they are all gases, and they will stay in their elemental form, which means that they're not going to bond with any other atom. They're not going to react because their valence electrons are already full. Okay, so let's look at group 7. Group 7 wants all of these elements right here. They want to gain 1 electron to have a full energy level. Now, do you remember over here in column 1, group 1, they wanted to give 1 away. So group 1 and group 7 are very reactive. As a matter of fact, group 1 and group 7, very rarely will you find the element by itself. It's going to be bonded to another element. Group 1 and group 7 will bond together. And that will help them fill their energy levels. Now you'll also notice some colors on the periodic table. See, anything to the left of this line right here are metals. They have high luster, which means they're shiny. They're malleable, which means they're bendable. They're ductile, which means they can be made into wires. And they're good conductors of electricity. with the exception of our friend hydrogen. Well, why is hydrogen, which is a gas, it's a non-metal, why is it over here with the metals? Because hydrogen has one valence electron. And so that's why we put hydrogen in group 1, because it has one valence electron. Now if we look over here at the green elements, we see that they are non-metals. They're often gases, but not always. Sulfur can actually be found as a solid. Non-metals are poor conductors of electricity. They're not brittle, which means that they don't break easily. They're not malleable, they are brittle, which means they break easily, which means that they're not malleable, they're not easily able to bend, and if I can't bend them, I can't make them into wires, so they're not ductile. But then you see these special elements right here. These are called metalloids. They share properties with the metals and the nonmetals. So for example, silicon, which is right here, well, you have silicon chips in your phone or in your laptop or in the device that you're using to watch this. It's a good conductor of electricity. It's also brittle. So it has properties of both. Well, I hope this helps you understand a little more of the patterns on the periodic table. Thank you.